Okay, let's get started. Today we're going to talk about what InterSystems doing in terms of integrating InterSystems IRIS data platform with Apache Spark. We'll talk about a few things. First of all, why we picked Apache Spark and not anything else. There are a whole bunch of other tools in big data arena that we could have integrated with. We'll talk about a few concepts that are important to understand about Spark. Okay? We talk about some details, implementation details of the piece of machinery called InterSystems IRIS Data Platform Apache Spark Connector. According to our marketing, that's the first thing we should say introducing this. From now on, I can freely talk about Spark Connector. And the last part would be dedicated to machine learning with Spark and how you can utilize this machine learning within your InterSystems IRIS applications. That part actually would be kind of sneak peek or preview of what you can do at a Spark experience session that will be running every day during this global summit. And one of them would start today right after this session. So why Apache Spark? A few weeks ago, my colleagues sent me this test. Can you recognize the names of Pokemon versus the names of big data products? Right? I know something about big data and can recognize some of the names, but my kids beat me hands down with this test because they know all their Pokemons. Right? They got 100% of this test. I got like 70 or something. Though the question remains, why out of all this Pokédex of big data name and big data products we pick Spark? Well, multiple reasons. First of all, and probably most important, we see, and even more important, our customers see, Apache Spark is the dominating market leader in the area of big data data processing. Right? It has a whole bunch of appealing features. It's kind of your Swiss Army knife of data processing. It supports multiple languages. It has multiple libraries, native SQL support. Streaming is probably the most popular use case right now. It has very powerful machine learning library, which we'll be utilizing today, graph, and a whole bunch of other things. Spark is based on JVM, Java Virtual Machine. So whatever you have out there as your Java libraries, open source project, and so on, you can right away start using with your Apache Spark. Right? It's very fast. And due to high level of abstractions of Spark data sets, you have to write significantly less code than, for instance, with MapReduce. Right? And again, the very important point, our customers, especially on Wall Street and financial industry, make very clear demand. If you guys want to be in big data arena, you have to play nice with Spark. And that's what we did. So, InterSystems IRIS and Spark share similarities. We both horizontally distributed. We both all about high performance. Right? There are some synergies as well. For instance, we are the data platform. We store data. We process data. Spark doesn't have its own storage layer. Spark is storage agnostic. People use Hadoop HDFS. People use flat files, shared file systems, and so on. Databases as well. So in order to operate, Spark needs storage. In this storage, better be horizontally distributed and fast. And that's essentially what InterSystems IRIS data platform is. Yes?
So high-firing storage that you can system platform, somebody else has the high-fire storage platform with Spark, that layer?
Yeah, we'll get to the technical details of how exactly we implement that. But in essence, you probably already choose Spark because it's fast, right? In order to satisfy some of the use cases, you need fast data storage, right? And data storage that InterSystems IRIS have a few very unique advantages over, for instance, Hadoop. Hadoop is nice, popular, widely used. But Hadoop is well known, like you can push data into Hadoop, but try to change data inside the Hadoop. That's a very hard task to do. We are the database. We can do that, right? We can give you data to, for instance, to your machine learning models right away, right? Not days or weeks after your data warehouse acquired the data. We can give Spark access to transactional data at the moment it's being generated. Right? There are some libraries, there are some overlaps, but there are some complements. For instance, let's talk about machine learning. Right? InterSystems so far is not in the business of creating machine learning library or creating machine learning machinery. Spark has it. They figured it out. They have comprehensive set of machine learning that's widely used. But at the same time, and this is what I'll be showing you later today, you can export the result of this machine learning as your PMML model definition and run it natively at InterSystems IRIS. Right? So again, a whole bunch of complements and synergies between IRIS and Spark. How we do that? We implement data source API. So for developer, we look just like yet another familiar API, yet another familiar interface, but with a whole bunch of advantages, performance being probably the most important of them. So let's introduce some Spark concepts. The most important concept you need to understand about Spark is a data set. High level of abstraction. It's so that means very easy to write the code. It is distributed, and again, because of high level of abstraction, you don't really need to worry about how Spark would distribute workload. It would, right? It's all the complexity is hidden from you, and it's resilient. Right? That means it can survive the crash of the nodes. Again, the Spark is about doing a lot of calculations on commodity hardware, and commodity hardware tends to break more often than what you typically see in your traditional data center. Right? Spark can recover very nicely from that event, and we'll talk about how and why it does that. Right? Dataset. If you read some papers on website about Spark in its early days, you would most probably see the term RDD. Right? And this is where Spark started. Resilient distributed data set. Right now, if you're working with Spark or reading literature on Spark, you would most likely see the terms dataset and data frame. Right? There are some implementation differences. For instance, RDD is collection of Java typed objects. Dataset and data frame, it's collection of primitives with metadata on top of that. But for the purpose of this conversation, it's all the same. The main concept remains the same. Dataset and data frame in vast majority of cases would be more efficient nowadays, but again, from the conceptual standpoint, it's the same thing. Right? High level of abstraction, easy to write code. It's very fast. We'll see some data in a second, and it's a reliable thing. Now, it's easy to write code in Spark. Think about Hello World. Like if we're talking about introduction to any programming language, that would probably be println Hello World or something like that, right? In big data, that would be word count. You have a document, just show me how many words you have in this document. This is how you do it in Hadoop with MapReduce. Few pages of code. This is how you do it in Spark. 3 lines. It's easy. Spark hides all of the complexity of distributed architecture, and for you as a developer, it translates in code that's easy to write. It's fast. Again, comparing to Hadoop, you have to save your intermediate results into reliable storage in HDFS all the time. You don't have to do that in Spark. Spark is all in memory. Right? And especially in iterative tasks such as machine learning is essentially an iterative task. We try and adjust our model. Is it good? No? Better? Worse? If it's better, we move on. If not, we roll back, and we're doing thousands and thousands of iterations. So Spark is ideal for this kind of iterative tools, iterative tasks. And it's reliable. The key to reliability of Spark, and by reliability we mean if node crashes, we can still finish the job. is immutability of the data set. By immutability, we mean that there is no way you can go inside the data set and change the value in there. The only thing you can do is to translate or transfer one data set into another data set. If you want to pull the data from the data set, it's called action, right? You get in the data and presenting results to the user, right? So we have our original data in reliable storage, then we have set of in-memory data transformation that are dictated by your code, right? And then we save results into some reliable storage. If the node crashes, we know that because of immutability, nothing happened within this data set while data was processed. The only thing that's supposed to be happening is what's in your code. So your original data in your code is still in reliable storage. Node dies, who cares? You just recalculate the same thing on another node. That's the key to reliability of Spark. Another concept to understand about Spark is lazy execution. Just spend a couple of seconds looking at this code. Even if you're not familiar with Spark and Scala, you would probably understand what this code is doing, right? That reminded me of the good old joke. The biggest problem with all the programming languages is that they do exactly what you tell them to do and not necessarily what you meant them to do. Okay? Spark is refreshingly different. Like if you look at this code and think of traditional programming language executing that, we're reading the file from the file system. We translate the file to uppercase, like translate every single line, and we create a new data frame, lines up, that contains the same file with all lines uppercase, right? Then we're looking for lines that contain Spark, right? And again, if you'll write that in Python or in Java, this is what the system would do. It would do exactly what you instructed it to do and would execute line by line and finally would show you the first line that contains Spark, if any. Spark is different. Spark is lazy. There's Catalyst Optimizer that looks at this code and says, these guys want me to read the file. But he's not asking me for anything yet in terms of returning the results. Then he asks me to uppercase the whole thing. OK, good to know, but I'm not doing anything yet. Right? Then it asks me to find the lines that contain Spark. OK, did he ask me about anything to print out or to give to him? No. Finally, we have the action. Show me the first line. Catalyst Optimizer of Spark would look at that and say, hey, I'm not going to do all this. I would read the file line by line. Right away, I would uppercase the line. And if line contains the word Spark, I would output that to you, and I'll stop. So it does dramatically less work while executing your instructions. Right? And that's the key to a whole bunch of things we like Spark for, right? Performance and a whole bunch of optimizations being one of them. So if you'll think about the way Spark works with databases, in essence, database is the logical extension of this lazy execution for Spark, right? Again, look at this code. You don't have to understand Scala to figure out what's going on, right? We open in the JDBC connection, we're reading the table sample.person, and then we asking for only names of the people that live in Boston, right? Again, Spark would first, look at the first few lines, then it would ask the JDBC driver in this case, hey, are you capable of doing predicate pushdown or not? Like in case of flat file or HDFS, the answer would be no. So it would have to load the whole thing and then give you the answer processed in this data inside Spark. But JDBC is already intelligent enough to do this kind of thing, right? So the driver would advertise to Spark, hey, I can do predicate pushdown. So you can ask me to do less work. So, and this is what Spark would do. This is the query that would actually be set to the database. So database became extension of this beautiful lazy execution architecture of Spark, right? What we do in our Spark connector, we just push in that as far as possible, right? And we'll talk about that in a second. So if I want you to remember three most important concepts about Spark, that would be concept of dataset, data frame, or RDD, depending on like paper of what year you're reading. Lazy execution, predicate pushdown. Now, Spark connector. Let's think about Wishlist, what we might want connector to the database to do for Spark, right? First of all, it has to be convenient API, right? We want people to look at the code, understand it right away, and this code better be organized the same way as any other data or database adapter Spark has. Predicate pushdown, as much as possible. We want to do database work and Spark to do Spark work. Right? And that's very important in terms of, are you doing that against one table only? Are you doing that against joins, against multiple table or SQL statements? Are you doing that against aggregates and so on and so forth? So we want as much as possible processing to be done on the database side, not on the Spark side, right? So Spark would be happy. And if both your Spark and your database is distributed, you better utilize this distributed database architecture, right? And if you look at the built-in Spark JDBC data source, right? Spark comes with data source for JDBC, HDFS, flat files, and a few other formats. And your database is distributed. If you make it talk through JDBC, you'll essentially make Spark driver or Spark master to talk to shard master. Like let's say it's InterSystems IRIS data platform. So this thing in the middle becomes your bottleneck. Right, you can add explicit parallelization, say, hey, look at this column and say, parallelize it into 5 threads, and one would take records from 1 to 1 million, another one from 1 million, 1 to 2 million, and so on. Right, so there's some options for parallelization, but in essence, one way or another, you will be bottlenecked in this connection, in this case, shard master, right? What we're doing with InterSystems IRIS Spark connector, we turn it around. So if you have distributed sharded database of InterSystems IRIS, and you have multiple shards there, and you have, again, distributed Spark, and Spark node is located on the same node as shard, right, we let Spark worker connect directly to the shard. And not only that, within this connection between work and shard, we'll do implicit parallelization. So this Spark connector is way more intelligent than your JDBC driver, right? Not only it would utilize the fact that the Spark node and shard node are collocated, it would do parallel execution as much as possible. It would basically take some of the functions of SQL optimizer onto itself, right? And the result, this is the result of TPCH tests, whole bunch of queries, and on average, Spark connector performs at least 10 times faster than your JDBC driver. Right? We want Spark to run fast, we want data to be delivered to Spark fast, and this is the result we achieved in our internal tests. In terms of API, again, if you don't know Spark Scala, you still can read that. If you know Spark Scala, say, oh, got it. I know how to work with this because that's the syntax that any other file system or database driver would use for Spark connector. So Spark connector is plug compatible with JDBC syntax. So if you're now using JDBC driver to connect to any other database in your Spark, the only thing you need to change is the type of the data source. Like all the options, everything else would remain the same, right? So it's very little change to your Spark code to take advantage of Spark connector. The biggest performance benefit is probably due to the fact that we can utilize the fact that Spark node and shard are collocated on the same node, right? We don't waste time, we don't waste cycle on networking. Okay? It has implicit parallelization. So Spark node and shard node don't talk single-threaded. Like Spark connector is intelligent and it would utilize all the connections possible that make sense to satisfy your query faster. And finally, predicate pushdown. JDBC would be limited to single table only. We're not limited to that. We can do joins. We pretty much can do predicate pushdown against any SQL query that you can imagine, right? We kind of chipping away on things like aggregates, sums, and so on and so forth. So it's kind of moving target, but we're already way ahead of what you have in terms of stock JDBC driver. Now, machine learning, the most exciting part. There was a question, and I'm glad that question was asked today on the keynote session, what we're doing with machine learning, right? There's no way we'll have time to give you a comprehensive introduction in machine learning because it's like a whole bunch of things going on in machine learning. It's a very interesting subject. But just 5-minute introduction, I think the best we will start with the way traditional programming is working. In traditional programming, you have a human being who writes code, and this code turns input into output. Input and output can be totally different things. It can be mouse click into the transaction going into the database, or it can be batch processing, whatever. Right? But you have input and you have output. But what's important, that code is written by a human being. If you think about machine learning, you have machine learning machinery consuming sample input and output. This is what input looks like. This is the output I expect you to generate. And then again, that's just for supervised learning. There are a whole bunch of other types of machine learning, but we're doing supervised learning today. And then machine creates the code. The other term, the proper term in machine learning would be the model that turns actual output into actual input into actual output. So basically, we're not trying to describe what you need to do. We showing you example and hope you'll learn from that. And that's essentially what machine learning does, right? So in essence, you have like machine creating machine, right? You may think about some scary things about machines taking over. If you think about that, you're probably paying too much attention to what Elon Musk is saying. We're not exactly there yet. We're moving. We're moving towards the more and more independent machines, but humans still have the role. Human would pick what model do we train, human would select the features, do hyperparameter training, and so on and so forth. The most important thing about machine learning is data. If we're talking about traditional programming model, you'll probably be okay, at least from functional testing standpoint, with a couple of hundred records of fabricated data. Machine learning would not work with that. Machine learning, if you have fabricated data, that means garbage in, garbage out. The data have to be normalized, cleaned, deduplicated, whole bunch of other things. You need to produce the clean data, and only clean data should be fed to this machine learning thing, right? The second important property of the data is quantity. You need a lot and a lot of real data. And again, in healthcare, like financial services, telco, Internet of Things, all of them probably have more than enough data to train their models. in healthcare situation is different. First of all, yes, you have to produce the high quality data. That means it has to be normalized in terms of terminology, deduplicated, cleaned up, and so on. But if you're trying to make a prediction on some rare condition, and I've been on multiple conferences where people talk about machine learning in healthcare, saying, hey, one hospital would not have enough data to train your model. So anybody here works with health share? Okay. Which piece of health share does exactly that? Cleans the data and aggregates the data from multiple facilities. Matt? Yeah, Health Insight. So Health Insight is, by definition, the perfect data source for machine learning already, because it does quality of the data and quantity of the data by aggregating data from multiple facilities, which is very important for machine learning. Right? So let's go to the demo. And demo would be predicting your New York City taxi ride. The description of the conference, the original description, talks about predicting your taxi fare. And we looked at the data that was made available by New York City, and this data that we'll be using right now and that we were using in the, will be using at the XP lab is data from Yellow, Green Taxi, and Uber. So if your task would be optimizing your fare, like any machine learning model would give you one and only one answer: use Uber. Right, so we kind of tweaked that a little bit, and we're predicting not the fare, but the speed with which you'll be traveling. Right, so let me switch to the virtual machine that we'll be using for training. I wouldn't run all the paragraphs. I really want to invite you to the Spark Experience Lab. We'll be running one every day. There's still spaces available on the session that would be starting 15 minutes after this one, Experience Lab. But in essence, what we'll be doing there, we'll be loading data using Spark, and this is the code to read data from flat file, right? And then save this data into the sharded InterSystems IRIS system. Again, if you're familiar with Spark, you would instantly recognize this syntax. It's nothing new here. But in this particular example, Spark, in essence, acts as ETL tool, right? That can take data from any format that Spark understands and stuff it into the InterSystems IRIS the most efficient way possible, right? The second thing that we're going to be doing there is exploring the data. Yeah. So I'll just switch to my local backup because we're having some connectivity problem to the main system. But what we're going to be doing is we analyze the write patterns with the hour of the day. We'll analyze the patterns with the day of the week. Right? There are a whole bunch of different options that you have to connect from your InterSystems IRIS data source into Spark. You can do the standard JDBC. You can do combination of SQL and Scala. You can do pure Scala, but a whole bunch of options and flexibility in terms of how you can connect to the data. Right? You have some nice geographical visualization of where pickup happening. If you think about this little void in the middle, that's Central Park. This is where pickup's not happening, right? But at the end of the day, you'll get your data source that contains your time of the day of the week, distance that you're going to be traveling, and the value that you need to predict how fast you'll be traveling. Right, so let me switch to the machine learning part. And in machine learning part, we'll be doing the exploration of this data by the machine learning, right? And again, we'll run it. It runs a few minutes, so I wouldn't waste your time in here, but you're very welcome in 15 minutes after the end of this conversation to go to Spark Experience Lab to look at that. Right? But at the end of the day, as the result of the task, you would get the model that can predict your ride with around 68, 69% accuracy, like how fast you'll be going. And the thing I want to show you right now is how you take this model, like generated by Spark, and use it within InterSystems IRIS by itself. So I would skip the copy-paste exercise, but in essence, you have your original data source as either SQL or Scala. We'll use SQL in this particular example because SQL is something that IRIS would understand natively. Right? I know Benjamin is smiling because he's a big advocate of Scala-only approach. The resulted model that we do have here is nothing but machine-readable XML. So this is what Spark would generate for you. And you'll be able to use this kind of format to run this model right inside the IRIS data platform. See, that's okay. Exploring. I just want to see if I can make it work or not. And seems like I can now. So connection was reestablished. So I'll just run this thing and get back to that to see you Spark actually generating this XML code. Apologies for the network problems. And this is the machine learning part. Like this part with the large database that we have in the cluster I'm using right now, and that's cluster that's been provisioned by InterSystems Cloud Manager with 2 Spark worker nodes, 2 shards, and a few other machines, for instance, hosting Zeppelin. Right, it would take a while, but in the meantime, let me do the import part. So we have this XML-based model representation, and we have the SQL data source. Okay, let me switch to my local copy of InterSystems IRIS. Switch to the samples namespace, and we have a tool here called PMML model tester. Let's create a new model based on this PMML file. As you can see, we practiced quite a few times, but we never practiced in that particular room to figure out that we might have connection problem. And we import the model. Yeah, import takes just a couple of seconds because in essence what we're doing is we generate in the class that contains this model and generating a whole bunch of code on top of that. Here's our data source, which is the same SQL that we executed in Spark, but now we execute it outside of Spark. And let's run it. So here are the results. We can check the statistics on all the possible values, false negative, false positives, and so on. But we got a pretty good 69% result. And we train in the data on one subset of data. We're testing the data on the other subset. So that's real values. So we don't mix in our training and test data set in here, right? At this moment of time, this PMML model already operates independently of Spark, right? So going back to the question that been asked at the keynote, that's one of the ways to add machine learning and artificial intelligence to your InterSystems IRIS-based applications. You can use Spark for machine learning. As soon as your model is ready, you have a choice. Keep it in Spark and use Spark, Spark Streaming, anything else to get your model, use data in IRIS to enrich the data to feed in your model. If you think about fraud detection, for instance, right? Fraud detection, the triggering action that you need to verify, do I approve this transaction or not, is that transaction, like someone trying to buy the gas at the gas station with your credit card. But to make a decision, is it fraudulent transaction or not, you have to look at a whole bunch of other things, like where this transaction happened, the same day transactions that happened before, and so on and so forth. So even if Spark by itself is capable of executing the model, in way too many cases, you need to enrich the data from the historical information that would be stored in your database, right? And this is where IRIS is your perfect storage layer, because the data appears in IRIS at the moment it was generated. It's real time or close to real time, so you can train your model on historical data, and you can execute your model on mixture of real time and historical data, like recent historical data, which is very important in many cases. So let's get back to our model. Execution is completed. It took 1 minute and 44 seconds, and this is the same XML that I had in my local machine. I just skipped the boring copy-paste part of exercise, but in essence, I can do copy-paste from this Zeppelin notebook, do the same exercise, and execute this model right within the IRIS. So let's get back to PowerPoint for a second. Oh, again, just to summarize what you can do with Spark machine learning and InterSystems IRIS. Like, first of all, you can use Spark as ETL to get data into IRIS, and that would be extremely efficient, like way more efficient than using standard JDBC, because the same way we can select the data efficiently in parallel using all this Spark workers and so on, we can put data in IRIS, right? Then we can use InterSystems IRIS to feed sample input and output in the machine learning, create the model. This model is being exported as a flat file in PMML format. Then this PMML can be used to generate InterSystems IRIS-based machinery. And at the end, it would be used to execute this model. You can do it here in Spark, or you can do that right in IRIS. And at this point, it's independent from Spark. You can still get back to Spark, improve your model, train it on additional data, and so on. But frankly, if you have a model, you can execute that inside IRIS. So I'll be happy to take any questions. As questions are tough, we have really smart people on the back who can answer. Jonathan and Benjamin, who are responsible for development of Spark connector. I really invite you to sign up for Experience Lab, where I know connection is there and working, and you'll be actually doing like all the data load, data exploration step, machine learning. As an additional bonus, the last exercise you'll be doing deep learning. So if you want to put deep learning in your resume, how sexy is that? Right? Just sign up for Experience Lab. Right? I hope you all downloaded the application. You can rate this session on this application. Recording will be available, and there are a whole bunch of people that would be happy to talk to you about IRIS and Spark at the Technology Exchange Hall. Thank you very much, and I'll be happy to take any questions. It's two-stage process. Like when we train the model using IRIS, right, the first step would be to load data into IRIS and then let Spark use this data through Spark connector, right? So we can train model inside Spark. After we export it to PMML and run it inside IRIS, that would be like inside IRIS connection. So it's the same SQL, but no Spark or Spark connector involved. So we have this data in IRIS, And the data set we use to train it on the big cluster out there in the cloud is different than data set I'm used to test that, but the outcome is pretty much the same. Yes, I have the data preloaded on my local machine. Yeah, Spark is just one of the examples, but we put a lot of effort into optimizing that particular piece of machinery, because if you really want to train your model on a lot of data, Spark is probably the most efficient tool. In terms of convenience and number of algorithms available, people might choose Python for that, but as long as Python can output the model in PMML, IRIS would be able to execute.